SolidWorks Simulation, Lecture 8, Part 2, Transient Thermal Analysis. For the first preparation step, we can load the software. The second preparation step, load the toolbar, and opening a study, which is thermal study. And actually, we have finished with the first step by drawing a 3D model and opening a study. But within thermal analysis, there are two types. The first type is steady state, and the second type is transient. Within transient analysis, we need to define the total time and time step for the transient analysis. But for steady state, the time goes to infinity, and the system reaches thermal equilibrium. So the first major difference between transient and steady state thermal analysis is the definition of the total time. This is the first major difference. So we have finished with the first step. For the second step, the material, I'll use aluminum alloy 6061 as the material for the heat sink. And for step 3, I'll use the default mesh. And I'll hide the mesh. Step 4, I'll apply the loading, which is the 28 watts heat source. And for the boundary conditions, I'll define the convection on all surfaces except for the bottom surface, which is in contact with the CPU. And then the convection coefficient for stagnant air is 10 watt per meter square K. And the transient ambient temperature will be 25 degrees C. This is the 25 degrees C. So we have a stagnant air condition for ambient temperature of 25 degrees C for all the surfaces which is in contact with the air. And this is the condition for convection. And I'll define the icons smaller because it is too large an icon. So I'll make it 20 to make it smaller. So now, the second major difference between transient and steady state thermal analysis is the initial time, initial temperature. So we define the initial temperature. Make sure that you don't press this button. No, never. You have to activate the selection filter in SolidWorks and choose body. And choose this body because you don't choose the surface, because there are a lot of node points or elements within the body, not on the surface. So you cannot choose exposed surface. You need to choose the whole volume to define the initial temperature to be 25 degrees. If you choose only the surface areas, then only those areas are defined as the initial temperature. And then this interior portion of the material is absolute zero temperature, which is minus 273.15 degrees C, and the result will be totally wrong. So it is very important that you choose. Actually, this is not a very good icon here. It is misleading icon. Be very aware about this. Okay, so now we have defined the initial temperature of the body to be 25 degrees C. And this is the second major difference between transient and steady state thermal analysis. As I said before, the first difference is the total time and time step. And the second major difference is the initial temperature of the system. And also, it is very important to choose initial temperature, not the temperature. If you choose the temperature, it will be the temperature all the time. So you need to choose initial temperature and then not clicking on this icon. Make sure that you choose body using filter and then choose the whole body. Okay, now, if you do this correctly, and then things will be good. So now we have proceed with 5. The step 5 will be the solution phase, and then there will be 120 steps. So I'll stop recording. I'll pause. Okay, the solution took about 1 minute to complete. So I probe. Before I probe, I'll make sure that the unit is right. I'll make the unit to be degrees Celsius, and the format of the number will be floating point, and the number will be 2 digits under decimal, and the maximum temperature will be 101 degrees C. And now we'll probe for the same point as the last one, which is this point, and the temperature is almost the same, but the difference is that when we click on this point, we can make the system draw a time profile. And this is the time profile for the system. You can see that the temperature rises from 25 degrees C to this temperature, which is 96 or so. So the temperature of the point rises from 25 and increases until the time goes to infinity, and the temperature reach the temperature of steady state condition. So this is the temperature for the steady state condition, which is 96 degrees C. So we can see that actually the steady state solution is a solution when time goes to infinity and the system reaches thermal equilibrium. You can also save the curve as the Excel file in maybe desktop, and you can manipulate that later. So this is the lecture 8 part 4, transient thermal analysis.